Hello all, my name is 𝗟𝗏𝗃𝗲𝗹. Welcome to Smart Indoors YouTube channel, your one-stop solution to face all the tech interviews. Today, we are going to discuss the first 4 problems of the latest CodeChef contest, Starters 197 Div.3. Without any further delay, let us begin. Let's start with the first problem in Div.3, bowling balls. Bowling balls has come in 11 total sizes, an integer weight between 6 and 16. In a bowling event, chef is given a total of n bowling balls, in which the ith one having AI pounds. Some of the bowling balls may have same weight as the others. Chef can use a bowling ball which is at least x pounds and at most y pounds. Find the number of bowling balls chef can use. Okay. Input format, first line contains t and each test case contains multiple lines. First line contains 3 integers n, x, y. N is the number of bowling balls, x is the minimum weight and y is the maximum weight. And here you are given weights, the next line given weights. Okay. Output format, you need to output a new line, number of bowling balls. Let's also look at the constraints. So test cases are 100, n is 100, x and y are from 6 to 16, array elements are from 6 to 16. Let's try to understand the sample test case. So first you have 3 test cases, 4 bowling balls with minimum weight 7 and maximum weight 10. So from 7 to 10 we have 2 bowling balls here, right? So the output has to be 2. Yes, it is 2. Next test case you have 5. From 6 to 16 you have 1, 2, 3, 4, 5. So the output is 5. From 7 to 10 you don't have anything, output is 0. So it is very simple. You will read the input. When reading the elements, you will check the number of elements in the range x to y. So let's quickly code the problem. First line contains t and t test cases. So while t minus minus, you are given 3 integers in the first line, n, x and y. So let's read the input n, x and y. After that you are given array elements. So here we don't even need to take the array elements. What I will do is I will iterate over n times and then I will take some k. I will read that k and I will check if k is in the range or not within x and less than or equal to y. If it is, we need to increment our answer, right? So I will take variable count. At the end I will print count. Let's run the code. 250, it is matching. Let's submit and check. Yes, it got accepted. Let's look at the second problem. All odd prefix sums. You are given an array of size n. Can the array be rearranged such that all the prefixes which are non-empty of that array has an odd sum? Okay. Formally, does there exist a rearrangement B of array A such that B1 plus B2 and so on Bi is odd for every I 1 to n? Okay. Output yes if it is possible and no otherwise. Okay. First line contains t, the number of test cases, and then for each test case we have n, the size of the array and the array elements. Yes if it is possible to rearrange, no otherwise. Okay. Let's see the example and try to understand. 3 test cases, only one element, that is 1. So if there is only one element, there is only one prefix which sum is 1. So we need to print yes here. Let's look at the next test case. There are 2 elements in the array, 2 and 4. No matter how I arrange, like 2 or 4 or 4, 2, the sum, the prefixes are always even. So I need to print no here. For the third test case, 3 elements 2, 1, 2. If I arrange it as 1, 2 and 2, I have an odd sum here. If I take this prefix, I have 1 plus 2, 3, which is again odd. If I take all the 3 elements, 1 plus 2, 3, 3 plus 2 is 5. So this is yes, I can rearrange so that every prefix will have an odd sum. So if you are clear with the problem statement, pause the video here, try to think of a solution. Let's try to think of a logic. So if I have only one element, and if it is even, can we get an odd sum? No, right? So if I can somehow bring an odd element, if I have an odd element at the first place, its prefix sum, like its prefix till this point is odd, right? For the next element, here I can have two elements. Either it can be even element or it can be odd element, right? Now if I add an odd element with even element, will I get the result as even or odd? Similarly, if I add this odd element with another odd, will I get even or odd? If you observe, whenever we add an odd element and an even element, we get the result as odd. When I add odd element plus odd element, I will get an even, right? Even on the other way, even if we add even and even, we get even only, right? So to get odd sum, we definitely need to have an odd element and an even element. And we also know that the first element should always be odd. So the next element should always be even, yes. Now suppose if there is a third element. To make this prefix as odd, what should we take here? Even or odd? Till here the sum is odd. So if I add odd plus even, I will get odd again. So definitely I need to have one more even here, right? Yes. So no matter how many elements I have, I always need to have only one odd element. Only one odd element, right? If I have only one odd element, then we can make odd prefix sums for all the elements. Yes? So let's start coding this problem. First line contains t. And then for each test case, you are given n. Next line contains n elements. So we know that there should be only one odd element, right, to make all the prefixes sum as odd. So I will just take variable odd, initially 0, and I will count the number of odd elements. I will read it as k. Reading, if k is odd, I will do odd plus plus. If at the end, if odd is equal to 1, that means we can make that arrangement. So I will print yes here. Else I will print no. For this yes, no and yes, let's try to submit. Got accepted. Let's start with the next problem. Good ranking. There are n contestants numbered 1 to n. Your task is to make them participate in some contest and then manipulate the ranking in a particular way. In each competition, the rankings of the contestants can be considered to be a permutation. Okay, from 1 to n. A contestant A is said to beat contestant B in a particular contest if A occurs earlier than B. Okay. The following condition should hold. For each pair, for every pair A comma B, such that A and B lies between 1 and n and A and B are not equal, there exists at least one contest such that A beats B. Your task is to choose the number of rankings, let's say m, then print m permutations, the rankings of each contests. You can have at most 10 contests, so ensure your contest lies from 1 to 10. Okay. Input format only one integer, and you need to print the contest in such a way that each A comma B exists such that A beats B. Okay. Try to understand the problem statement and try to come up with a solution. Let's try to understand this problem with the example. If my n value is 3 and let's say I conducted a contest and the winners are 1, 2 and 3. Winners are 1, 2 and that means he got the first rank, he got the second rank, he got the third rank. Okay. Now, what are the different pairs of A comma B that are possible here? 1 comma 2, 2 comma 1, 1 comma 3, 3 comma 1, 2 comma 3 and 3 comma 2, right? Now in this, these pairs satisfy the given condition, right? These pairs satisfy the given condition because here if I take this as A comma B, A is the winner compared to B and A is the winner compared to B, and also for the third test case, for the third one, A is the winner when compared to B, right? But what about these pairs? These pairs are not satisfying the condition. So for this, I need to create one more contest so that winner will be 2 and winner will be 3 and winner will be 3 when compared to this, right? Can you get a contest where which satisfies all these 3 conditions? Can you get that contest? Can I say if I create a contest 3, 2, 1, all these 3 conditions get satisfied. 2 is the winner when compared with 1. 3 is the winner when compared with 1. 3 is the winner when also compared with 2, right? Also try this for n equal to 4. Try this for n equal to 4. So now if you observe, whatever the value of n is, I can create 2 contests, right? I can create 2 contests. The first contest winners are from 1 to n. The second contest winners are from n to 1, right? Such that every pair A comma B and where A not equal to B have at least one contest where A beats B, right? Yes or no? So if you are clear with this, let's go ahead with the code. Good ranking. We know that we can create 2 contests such that the first contest winners are from 1 to n and the second contest winners are from n to 1. So the first line contains n, int n. Let's read the value of n. In this, we need to print the number of contests that we are going to print, right? Every time we are only printing 2 contests. So cout 2. After that, in the next line, we need to print all the n elements. So int I equal to 1, I less than or equal to n, plus plus, I will will see out, I will print I, right, and some space. After that I will print a new line. After that, from n equal to 1 and I minus minus, see out I. Yes, it got accepted. Let's see the next problem. Problem name as split. For a given binary string S, f of s is longest non-decreasing subsequence of s. So for f of 0011 it is 4 and f of 0101 is 3. F of s is longest non-decreasing subsequence. Maybe length of longest non-decreasing subsequence, right? So here, what is the length of longest non-decreasing subsequence? If I have 10 elements, subsequence is something like I can pick this or I can leave this. I can pick this or I can leave this. The order has to be maintained. So I can pick this, I can leave these two, and I can directly pick this as well, right? But the order has to be maintained, the index order. Okay, so here I can pick all the 4. Even if I pick 0, 0, 1, 1, it is non-decreasing. It is not decreasing, not decreasing, not decreasing. So I can pick everything, and the length of this longest non-decreasing subsequence is 4, right? Now let's look at for the second test case. 0, 1, 0, 1, 0, 1, 0, 1. Here I can pick 0, 0 and 1, which is non-decreasing. 0 to 0 non-decreasing, and again this non-decreasing. But if I pick this, I cannot pick any of this, right? Yeah, we can also pick this. This is also non-decreasing. The length is 3 again. It is not decreasing. Okay, the length is 3. So you are given a binary string S of length n, and you are also given an integer k. So you are given a binary string of length n, and also you are given some k. Consider splitting S into k substrings. Consider splitting S into k substrings, T1, T2 and so on. So you need to split this into multiple substrings, T1, T2 and so on, Tk. So when you add or when you concatenate all this, you will get the original S again. Okay. Now the score of such a split is defined as, so this split score is defined as minimum of all the T1, T2 and so on, f of T1, f of T2 and so on, f of Tk. Okay, this is a score for the split. Find the maximum possible score possible by choosing a suitable split. You need to find max of all these possibilities, max of all these splitting possibilities. Okay, this is the problem statement. Try to read the problem statement once again and try to get more clarity on the problem statement. So let's try to understand this problem with this test case 6 and 2, and the string is 0, 0, 1, 0, 0, 1. So here I can split this string into 2 parts. That is, if I somewhere split here, this will be T1, this will be T2, right? I can split it here or here or here and so on till here, right? So let's try to find minimum of f of T1 comma f of T2. Okay, if I split it here, this will become T1, this will become T2, right? So what is the value of f of t1? What is the length of longest non-decreasing subsequence here? It is 1 here, right? And here it is 4, right? So minimum of 1 comma 4 will be 1. So as of now, this minimum value is 1 for the first split. For the next split, it is 2 here and 3 here, right? So minimum of 2 comma 3 will be 2 again. Now if I split it here, this is 3, this is also 3, right? So minimum of 3 comma 3 is 3. If I split it here, here you will get 3, here you will get 2. Minimum of 3 comma 2 is 2. And the last split, here it is 1, so here something greater than 1. So minimum of those is 1. So maximum of all this is 3. So that is your answer, right? So if you are clear with the problem statement, he asked us to find something like maximum of all the possible minimums, right? So whenever there is something like max of min or min of max, we need to use binary search. But how can we use binary search here? How can we use binary search? Try to pause the video here and try to think of a solution. Let's try to understand using this example. Okay, we can split it in multiple ways, but here we are not worrying about splits. I am assuming that my answer is 2 or my answer is 3 here. Let's take 2. If I take my answer as 2, so what I will do is I will start here. I will check if I can make a split with f of t1 as 2. Here, when I am at this point, the length of longest non-decreasing subsequence is 2, right? So I will make a split after this. Okay, and now again I will try to check if I have longest non-decreasing subsequence of length 2. If I go here, the length of, I will get it here, right? I can take these 2 zeros, I will get it here, and there are some elements left. We know that the answer here is 2, so even if some elements are left, I can consider the entire thing as a split, because we only need to make 2 splits here. I can consider this element. Even if I consider this element, my length will be the same or it will increase. That's it, right? Or it will increase. That's it. So I will split here. I got 2 here, I got 2 here. So I can say that my answer is 2. It can also be greater than 2, but it can never be less than 2. Yes or no? Right? It can never be less than 2. So, do you see this pattern? If my answer is 5, definitely, if I can say my answer is 5, definitely this can never be my answer, right? And similarly, if 10 is not my answer, if I have a string and I checked it and I got 10 as not possible, then definitely 11, 12, 13, 14, 15 are also not possible. So I can remove this, right? Do you see this pattern? Here this is being true until some certain point. After that it is becoming false, right? You need to find the last true value. So whenever you see this pattern, we can apply binary search, right? But the only thing which we don't know is how will you check this? How will you check this part? How will you check if the length of the longest non-decreasing subsequence, right? For now, assume it as a black box. We will discuss. But before that, I want you to think about that. This is the third test case, right? Where this is our k, this is our string s, this is our n, right? So let me try to find the length of non-decreasing subsequence. For that, I will take the count of number of zeros initially, which is 0, and the count of number of ones, which is initially 0. Let me also take a variable split because I need to count the number of splits I am making. So initially 0. So here, when I am at the first character, which is 0, what should I do? I will increment the number of zeros. Okay. Again I got a 0, will again increment. So at this point, number of zeros are 2, ones are 0. We did not make any split. Let's keep the split out of this for now. Now, for the next character, I have a 1. What can I do here? What is our answer? What is the length of longest non-decreasing subsequence? 1, 2, 3, right? How will I get 3 now? I am getting 3 because I am taking this previous two zeros and adding 1 to it, right? So when I get a 1, I need to check the previous zeros. What is the count of previous zeros? If the count of previous zeros are greater than the count of ones, then I can take this as number of zeros previously plus 1. So it is 3 here, right? Now moving forward, I have a 0. What should I do? What is the, if I make a split here, what is the length of longest non-decreasing subsequence here? 1, 2, 3, right? So I'll simply increment the count here. Now at this point, what is the count? 4, 1, 2, 3, 4, incrementing the count here. Now when I am here, what is the character here? 1. What is the length? 5. But how will I get? I am taking the count of previous zeros and adding 1 to it. So which is 4 plus 1, 5. Right? Did you understand this? Now let's also bring split into the equation. Okay. Here I need to make 2 splits. Initially the count is zeros. So now I am taking my answer as 2, which we did previously, and checking if 2 is possible or not. Okay. Now I am making it as 1. We are done with this. Now here we will increment the value of zeros and we will move forward, right? As I got a partition where the length of longest non-decreasing subsequence is 2, can I say I can split here, right? As I am splitting here, can I make this count as 1? Yes. Okay, moving forward, I got a 1 here. What should I do? As we are done with this split here, can I say I can reset my count to 0? Because we are no longer involved with that zeros which are in the different split, right? Now, what should we do? We need to check the number of zeros in this partition, which are 0. So the number of ones will become simply 1, right? Now, at this point, what will happen? We're done with this. At this point, we will simply increment the number of zeros. After this, here, simply increment this. After this, here, you need to check the number of zeros. Number of zeros are 2. Number of ones are 1. So what to do? I will take the number of zeros and add 1 to it. So this will become 3 here. Subsequence is this, right? So as we got this, we can simply consider one more split here. We can actually do that here itself, but to explain this case, I went a step forward. Let's start coding this problem. First line contains t, so int t. I'm reading the value of t. Here, for each test case, we have n and k. So n and k. Cin n and k, and also we have a string s, c in s, right? After this, what will you do? Let's call a solve function which will help us to write the binary search code, and I am passing string s, n and k. What will this function return? This will return an integer result, and I need to print that result. Right? Now let's write solve function. Int solve, first parameter is string, and then n and k. So what is my search space here to do binary search? The lowest possible answer is 1, so low is 1. High, what is high? N is the maximum possible answer. So while low less than or equal to high, what will you do? You will find the mid, and mid equal to low plus high by 2. If I can split my string s of length n with at max k splits and get a mid, if I can get this, I don't need to check anything less than mid, right? So low equal to mid plus 1. But before that, I need to store my answer. My answer is mid, right? So I will take a variable answer equal to 1. Here in the else part, I can simply write high equal to mid minus 1. At the end, I will return my answer. Now how to write this can split function? The written type of it will be boolean, bool, can split, string, yes, and n, k, and mid. How will you check the number of splits? We will take a variable ones to count the number of ones. We will take a variable zeros to count number of zeros. And we will take split to count the number of splits that we are making, initially 0. Now we are iterating over the string character ch is yes. If the character ch is a 0, what will you do? Increment the number of zeros, right? Zeros plus plus. Else if the character is 1, what will you do? You will check the number of zeros first. If the number of zeros are greater than the number of ones, you can simply append this 1 to those zeros to get the longest one, right? So again here, ones is zeros plus 1. Else simply ones plus plus, right? After that, what will you do here? Once you get number of zeros and number of ones, what will you do here? You will check if we got mid length or not, right? If we got length of the longest non-decreasing subsequence as mid or not. So how will you get that? That is nothing but max of zeros and ones. So max of zeros comma ones, if it is greater than or equal to mid, what will you do? You will split here. So number of splits plus plus. After that, you need to make the number of zeros as 0 and the number of ones as 0, because we are starting with a new split again. At the end, what will you return once you are done with this for loop? You need to return something true or false, right? How will you check that? You will check if the number of splits are less than or equal to k, right? If the number of splits that you are making has to be greater than or equal to k, right? That's it, accepted. That's it, guys. Hope you like the content. If you like the content, please share with your friends and also subscribe to our YouTube channel for further updates.